Hello students, welcome back for the second part of laws of motion. Without any delay, let's get started. Question number 31. Okay. In question number 31, just try to observe this. A particle moving with a velocity v is acted by three forces shown by the vector triangle PQR. The velocity of the particle will be. So whenever if you get a triangle like this, according to triangle of vectors, sum of these vector addition of these vectors is going to be 0 actually, according to triangle law of vectors. According to triangle law net sum of all the forces acting on a particular point is equal to 0. That is F1 bar plus F2 bar plus F3 bar is equal to 0. Sum of all these forces is equal to 0. That means net force acting on the particle is equal to 0. If net force is equal to 0, A net is equal to 0. If A net is equal to 0, velocity is not going to be 0, it is going to be constant. Remember this. So, sir, why it is not 0 in the sense? Acceleration formula dv by dt. Acceleration is equal to 0 in the sense velocity must be constant. It must be constant. Constant velocity, constant differentiation only 0, right? It must be constant. Okay, ma? Next, question number 32, solution. So which option matches? I think option D is the correct answer for the question number 31. Okay. Next. So in this case, they are given three forces acting on a body as shown in the figure to have the resultant force only along y direction. This is the hint. To have resultant only along the y direction. The magnitude of minimum additional force needed is, okay, look at this. So this is the representation of forces they have given in the question, and they are asking final resultant force must be present only along y direction. That means forces along x direction must be equal to 0, right? So look at the hint they have given. Hint is F resultant must be along y-axis. Then what about forces along x-axis? Must be equal to 0. Forces along x-axis must be equal to 0. Let me check out. I have to divide these things into components. Then we have to find out what is the minimum extra force which is required. Okay, look at this. Now, if this is 60 degrees, this is going to be 30 degrees. Okay, otherwise, divide this 1 into 2 different components. This is going to be 1 cos 60. Another one is 1 sin 60. Okay. Next, if this is 60 degrees, so as these two vectors are perpendicular with each other, this angle is going to be 30 degrees. Now let me divide this into two components. This is going to be 2 sin 30 and this is going to be 2 cos 30. This is not going to be 30 degrees. They didn't mention about this. They didn't said that it is at some angle 90 degrees. They mentioned? No, they didn't mention. Then how can we take this is going to be 90 degrees? No, that is going to be not a correct thing. This is not to be taken as 90 degrees. So if this is 30 degrees, this is also going to be a 30 degrees, right? Yes, it is going to be opposite angle. Then you can divide this into two components, horizontal and vertical component. Vertical component of velocity is going to be 2 cos 30, which is going to be 2 sin 30. Okay, left side force. This is 4 sin 30 and this one 4 cos 30. I just have to observe only horizontal forces. Let me check out horizontal forces. This is going to be 2. right side. 2 sine 30 is going to be it is going to be 1 cos 60 is going to be 1 by 2. Just check out whether horizontal forces are equal or not. No, they are not equal. I am representing the forces here which are present only along x direction. One is towards left, which is 2 Newton. Another one is towards right, which is 1 plus 1 by 2, which is equal to 3 by 2, and it is equal to 1.5 newtons. To make horizontal forces Fx is equal to 0, I have to add 0.5 newtons along positive x direction, along positive x-axis direction. How much force I have to add? 0.5 newtons. Option C is correct. Very good. Next question number. Next topic is based on the common forces in mechanics. Okay. Now look at the question they are asking. Question number 33. Which one of the following statements is incorrect? That's what they are asking. Okay, the very first option is rolling friction is smaller than the sliding friction. Yes, it is correct. First option is rolling friction is less than static friction. Correct. Second option, limiting values of static friction is directly proportional to normal reaction. Static friction formula us into n. Yes, static friction is directly proportional to normal reaction. Yes, second option is also correct. Next, third option, frictional force opposes relative motion. Yes, it is correct. So for example, a block is placed on a horizontal surface, a force is applied towards right, then frictional force acts in the opposite direction of that object. Frictional force always opposes motion of the object. So third point is also correct. Now observe fourth point, coefficient of sliding friction has dimensions of length. Formula for frictional force is mu s into n. Let's say this is a limiting friction. From this, mu s is equal to Fl by n. Fl is frictional force, n is normal reaction. Both are forces only, so force units will get cancelled out. Mu s is a constant. It is a dimensionless constant. So that is the reason. So option 4 is incorrect answer. Okay, so option 4 is the right answer. Next, question number 34. 34 solution. Okay, a plank with a box on it at one end is gradually raised up the other end. Okay, as the angle of inclination with the horizontal reaches 30 degrees, the block starts to slip. Okay, super. This is called as angle of repose. The angle at which object starts sliding on the inclined surface is angle of repose. Very good. Mass of this block is m and its weight is, they have given, it is mg. Then object is sliding like this in this downward direction. Super. Now if theta is equal to 30 degrees, if theta is equal to 30 degrees, object starts moving. Object is sliding. And that is the angle of repose. And the formula for angle of repose is tan theta r is equal to mu s. From this we can find out the value of coefficient of static friction. Okay, look at this. The block starts slip and slides 4 meters down on the plank in 4 seconds. Okay, the coefficients of static and kinetic friction between the box and the plank will be. Okay, super. So they said at theta is equal to 30 degrees, the block starts displacing, nothing but sliding. That is the angle of repose, angle at which object is ready to displace. Okay, now we have a formula for angle of repose, which is tan theta r is equal to mu s. Tan theta r is nothing but 30 degrees, which is equal to mu s, and mu s is equal to tan 30 is 1 by root 3. 1 by root 3 value is 0.707. Sorry, 1 by root 3 value is 0.577. 0.577. So mu s is approximately 0.6. So from this is how we can find out the value of coefficient of static friction. Now look at the coefficient of kinetic friction. As object is started its motion and it is moving in a downward direction, so actually it is displaced 4 meter. They have already given in the question. So what is the displacement covered by this object? 4 meter. Okay, so in a downward direction. So it doesn't means that object is reached to bottom. I just represented here. So it is this block traveled 4 meters in 4 seconds. Okay, which force is responsible for displacement of the object on the inclined surface? Just divide this mg into 2 components, as this is theta, this is also, sorry, this is going to be theta, this is mg cos theta, and this is mg sin theta. So the force which is responsible for the block on the inclined surface is mg sin theta. Okay, now as object started moving, there will be a frictional force which acts opposite to its motion. That frictional force is kinetic friction as object is under motion. Let me represent this object in the form of a point mass. That is a free body diagram. Mg sin theta is downward. Upward it is Fk, frictional force. Weight component mg cos theta is perpendicular like this, mg cos theta. Normal reaction is always perpendicular to the surface. This is how it is represented. So this is the representation of a normal reaction. Normal reaction is always perpendicular to the surface. Always perpendicular to the surface. Now from this, so we know that mg sin theta is greater than Fk. That is the reason object started moving. First of all, let me find out acceleration. Acceleration is equal to mg sin theta minus Fk. Fk is coefficient of kinetic frictional force. Mg sin theta minus Fk is mu k into n. Then A is equal to A is F by m. I am just representing F only now. So then you have to represent F here. F net force. F net. Observe carefully. So which is mg sin theta minus mu s into, not mu s, it is mu k, right? As object started moving, as it is under motion, you have to consider coefficient of kinetic friction only. So this is Fk, mu k into n. Mu k into n is mg cos theta. So this is net force acting on the block which is responsible for displacement. From this we can find out acceleration. Acceleration is equal to g sin theta minus mu k into g cos theta. G sin theta minus mu k into g cos theta. This is the acceleration with which object is being slid. So what is the initial velocity of the object? Initial velocity is equal to 0. Okay, so it means it started its motion from rest. Okay, starts to slip in the sense initially starts to slip in the sense initially the block is at rest position. They gave one case here. So it is in t is equal to 4 seconds, object is traveling 4 meter. Let me use s is equal to ut plus half at square equation. So they gave s is equal to 4 meter, ut is equal to 0, 1 by 2, acceleration is g sin theta minus mu k into g cos theta into t square. T square is 4 square. So in 4 will get cancelled. 2 2s are. So final answer I am going to get is so from this 1 is equal to g sin theta minus mu k g cos theta into 2. They gave theta value in the question itself. What's the value of theta? Theta is equal to 30 degrees. So theta is equal to 30 degrees, and let me take g is equal to 10 meter per second square for the calculation. So 1 is equal to 10 sine 30 minus mu k into 10 cos 30 into 2. 1 is equal to 10 sine 30 is 1 by 2. 1 by 2 into 10 is 5. 5 minus mu k into cos 30 is root 3 by 2. It is going to be 5 root 3 into 2. So from this 1 is equal to 10 minus mu k into 10 root 3. From this mu k into 10 root 3 is equal to 10 minus 1, it is going to be 9. Then mu k is equal to 9 by 10 root 3. So from this we can answer like how can I convert? Let me write down. It is as 3 into root 3 into root 3 divided by 10 into root 3. Root 3 will get cancelled out. So then mu k is equal to 3 into 1.732 divided by 10. If you calculate this, approximately mu k value are going to get 0.5. So mu s is 0.6, mu k is 0.5. This is how we have to answer the question. Which option matches? Option A. No, not option A. Option D is correct. Is it clear, guys? Super. Next. Question number 35. A block A of mass m1 rests on a horizontal table. A light string connected to it. It passes over a frictionless pulley at the edge of the table, and from its other end another block B of mass m2 is suspended. Okay, let me consider a table. Observe this diagram, guys. Try to understand the terminology. A block A of mass m1 rests on a horizontal table. That means it is initially at rest position. Okay. A light string is connected to it, passes over a frictionless pulley at the edge of table. From its other end another block B of mass m2 is suspended. Okay, hope it is represented. At the edge a pulley is placed. From that pulley another block is being suspended. Okay, next. The coefficient of friction between the block and the table is mu k. Okay, so as the block starts moving down, this is how it starts moving, then frictional force will act on the block m1 in opposite direction to its motion, and it is equal to Fk, and coefficient of surface kinetic friction they have given it is as mu k. When the block A is sliding on the table, the tension in the string they are asking. Okay, so the very first thing you have to remember is tension in the string is going to be same. Note, what's the point here? Tension in the string is same. Once the string changes, then definitely tension is going to change. That's how we have to understand. Look at this, the representation of tension in the string. So tension in the string is always away from the point of contact. Let's say this is T. At this point it is going to be away from it, which is equal to T. Then, so there is a trick to find out net acceleration of the system and tension in the string. Let me find out in usual process, then we'll try to understand the trick based on this equation. Okay, let me consider block A. So let me draw free body diagram. So if you draw free body diagram, observe block M1. So there are two forces which are acting on block M1. One is tension in the string, another one is frictional force towards left. Normal reaction acting on that block is perpendicular to it and its weight acts downward, M1G. So as T is greater than Fk, object is moving towards right? As object is displacing towards right, let's say with an acceleration A, system is accelerating with an acceleration A, then which is greater, tension in the string is greater or Fk is greater? Don't say N and M1G are the forces which are responsible for the object to displace upward or downward. No, it is not. Normal reaction is always perpendicular to the surface. Just to represent normal reaction, I did represented it here. Next, so as T is greater than Fk, object is moving towards right. What is Newton's second law? Newton's second law is F net is equal to ma. Here it is. Here m is constant, right? So F net is equal to m into a. Now what is F net here? T minus frictional force, which is equal to mass of the block m1a. So T is equal to Fk is mu k into n, which is equal to m1a. T minus mu k into normal reaction is m1 into g, which is equal to m1a. So this is, let's say, equation 1. Now let me observe block 2. So mass of the block B is m2. Downward force is weight of the body, that is m2g. Upward force is tension in that block, that is T. As object is moving down, which is greater, m2g is greater or tension in the string is greater? Definitely m2g is greater than the tension in the string. Let me apply Newton's second law again, that is F net is equal to m2 into a, or else you just simply represent m into a. F net is nothing but m2 into g minus T is equal to m2 into a. So we know the value of tension in the string. You just let me substitute the tension here. Let's say this is equation 2. Substitute 1 in 2. That is m2g minus of, if you send this to right side, it will become plus, but here it is minus. So minus m1a minus mu k m1g, which is equal to m2a. So let me send m1a right side. So m2g minus mu k into m1g, which is equal to m1 plus m2 into a. So from this, acceleration is equal to m2 minus mu k into m1 into g divided by m1 plus m2. This is the acceleration of the system. If I know acceleration, if you substitute this acceleration in any one of those two formulas, we are going to get the answer. Let me substitute that and I will give you final answer. Substitute A in equation 2, which is equal to m2g minus T, which is equal to m2 into a is m2 minus mu k into m1 into g divided by m1 plus m2. Let me multiply that. So if you multiply here, m1 m2 into g plus m2 square g minus t, which is equal to m2 square g minus m1 m2 into g minus m1 m2 into g. So where is mu k? m2 square g minus m1 m2 into mu k, okay, into g. Super. So g will get cancelled. No, it is not. m2 square g, m2 square g will get cancelled. Send this t right side. So t in this step, in addition to t, you are going to get t into m1 plus m2. Okay, let me substitute that. Minus t into m1 plus m2. Okay, so let me send this outside. m1 plus m2, which is equal to m1 m2g minus m1 m2g into mu k divided by, not divided by. So from this t is equal to m1 m2 g is common, 1 minus mu k divided by m1 plus m2. This is the answer. Look at the option which is matching. m1 m2 into g, 1 minus mu k by m1 plus m2. Option B is correct answer. Look at this. Option B is wrong. So here if you send this to left side, it will become positive, right? It's gonna be positive. So option A is correct. Just check it out. Okay, next step. Question number 36. Observe question number 36. A system consists of three masses m1, m2 and m3 connected by a string passes over a pulley P. The masses m1 hangs freely and m2 and m3 are on the rough horizontal surface. Coefficient of friction is mu. Okay, so coefficient of friction is mu. Okay, then the pulley is frictionless and negligible mass. They're asking the downward acceleration of m1 is okay. And one more thing they have given. They said masses of all the blocks are same. m1 is equal to m2 is equal to m3. Okay, that's the condition we have to follow here, which is m1 is equal to m2 is equal to m3 is equal to m. Super. So this system I'm going to combine like a stretched system. Let me represent you that. So what is the weight of this body? First block m1, it is going to be m into g, correct? Because m1 is equal to m1. Next, frictional force will act on these blocks. On both the blocks, frictional force will act. So normal reaction acting on this block is n. So normal reaction on this block is also n. So what about weight of this body? It is mg. What about this body? Weight of the body is mg here. So in this system, m1 block is moving downward with an acceleration a. m1, m2 and m3 blocks are moving towards left with the same acceleration a. That is what we have to find out. Let me replace this system like a stretched system along horizontal direction. So there is a frictional force here F and this is F. Okay, let me combine these masses. Okay, so I'm representing the system like this. This is the easiest way to answer the questions based on the pulleys. Okay, let's say this is block of mass m and system mass 2m, which is on the horizontal surface. Definitely frictional force will act on this object as it is a rough surface of coefficient of static friction mu. So weight of the body which is acting left side, it is going to be mg. Just whatever the part which is hanging, this m1g, I'm just shifting along horizontal direction like this. That is the only difference you have to observe. So here it is frictional force F. Normal reaction acting on the block 2m is n and it is equal to 2mg. Which is greater? Normal reaction is greater, mg is greater or frictional force is greater? mg is greater, that is the reason system is moving towards left. So acceleration of the system is equal to F net by M net. F net is mg minus frictional force acting on the block divided by total mass of the system is m plus 2m, which is equal to mg minus frictional force is mu into normal reaction divided by 3m, which is equal to mg minus mu into normal reaction is 2m divided by 3m. So m will get cancelled out. So final answer acceleration is equal to, it is mu mg. So g into 1 minus 2 mu divided by 3. This is the acceleration of the system with which it moves downward. Option D is correct. Now question number 37. The upper half of an inclined plane of inclination theta is perfectly smooth while lower half is rough. So that I have shown in the diagram. So look at this diagram. A block starting from rest at the top of the plane will again come to rest at the bottom. Okay, super. So a block is released at the top of this inclined plane. Let's say block mass is m, which is released in the sense initial velocity of that block is equal to 0. While it is moving on the upper half from starting to the half of the length of the inclined plane, its velocity goes on increases because there is no any frictional force acting on that block. So when it reaches this position, its velocity is going to be maximum. Let's say velocity of the object is going to be v. So this is the initial velocity of the object which is moving on the rough inclined plane. When it reaches bottom surface, again its velocity came to 0. That means again block came to rest position. So velocity v final is equal to 0. Super. V final is equal to 0. This is what happening. Okay. In which case frictional force is present, in which case frictional force is absent, we should be in a position to decide. So when object is moving on a smooth surface, there is no frictional force. When it is moving on a rough surface, when it starts moving on a rough surface, definitely frictional force will act on that block, which will be in the same direction of motion or in the opposite direction. In the opposite direction of motion. This is the representation of frictional force, which is acting opposite to its motion. This is what kind of frictional force is it? Is it kinetic friction or static friction? It is a kinetic friction. Why we have to consider kinetic friction? Because object is moving on the rough surface. It is not at rest position. If it is at rest position, we have to consider static friction. As it is under motion, we have to consider kinetic friction. Direction of normal reaction is always perpendicular to the surface. Let me divide weight of this object into two components. One is along inclined plane, another one is along perpendicular to the inclined plane. This is how weight is divided. This is mg, and one more component. This is mg sine theta. Angle of this is theta, inclined plane, and this is going to be mg cos theta. Hope you understood the representation. If not, just go through this diagram alone once again. Okay, well, now I've divided this question into two parts, case 1 and case 2. That is positions. I am representing with different positions. Let us say this is position A, position B, and this is position C. Okay, now observe position A to position B motion. Case. So if the coefficient of friction between the block and the lower half of the plane is given by, that's what they're asking. They're asking coefficient of friction. Super. That is what we have to find out. Okay, let's get started. As they are saying only coefficient of friction, I just can represent only it with frictional force. That's all. Just represent it with frictional force. Okay. A to B region, is there any frictional force acting on that block? No, it is not, because that surface is a smooth surface. Let me represent it with a free body diagram. So downward force is going to be mg sine theta. So what is the displacement it is covering? It is covering a displacement of L by 2. It is covering a displacement of L by 2. So by the time it reaches the starting position of a rough surface or position B, it gains some velocity. Let me find out that velocity at position B. So what is the starting velocity? Initial velocity of this object is equal to 0. Then so v square is equal to u square plus 2as. Let me use this formula. Initial velocity is equal to 0, v square is equal to 2 into a is g sine theta. Here mg sine theta is force, which is equal to force. Then to find out acceleration, I have to write down it is as a by f by m. So m will get cancelled out. Then I am going to get g sine theta into s is the displacement along the inclined plane, which is traveling only L by 2 distance. So 2 will get cancelled out. Then v square is equal to gl sine theta. Super. Let me keep this value as it is. This is going to be initial velocity of the block on rough inclined surface. Okay. Now again this block I am representing a free body diagram. Let us say this is equation 1. Free body diagram of the block from B to C region. Okay. Weight acting on this body is again mg sine theta. Now frictional force will act on this body in the opposite direction of its motion, that is F is equal to mu into n, where n is normal reaction, which is equal to mg cos theta. Normal reaction is represented like this. This is n. So object is displacing again L by 2 displacement. When it reaches to the bottom, its velocity is going to be 0. Okay, super. So right now, when it is at position B, it is having some initial velocity. That initial velocity is v. So it is going to be final velocity. So let me find out or let me use those kinematic equations and try to find out the answer. Okay, look at this. So again use v square is equal to u square plus 2s. V square is equal to u square plus 2as. So final velocity is going to be 0. Initial velocity is the velocity at position B, that is u square is equal to gl sine theta plus 2. A is going to be g sine theta. No, it is not going to be g sine theta. We have to find out net acceleration. First of all, let me find out net force acting on it. Net force is equal to mg sine theta minus frictional force. So which is equal to mg sine theta minus frictional force is mu into n. What is n? N is normal reaction. Mg sine theta minus mu into normal reaction is mg cos theta. So let me substitute. This is F net. What about acceleration? Acceleration is equal to g sine theta minus mu g cos theta. This is the net acceleration acting on the block at position B. Let me substitute that. G2 into g sine theta minus mu g cos theta into S. S is L by 2. Let me substitute this here. G is 0 is equal to GL sine theta plus 2 will get cancelled. It is going to be GL sine theta minus mu G cos theta. Okay. So from this you can write it down as mu G cos theta is equal to 2GL. So this is, you are going to get L here. So mu GL cos theta 2GL sin theta. GL will get cancelled. Then mu is equal to 2 times of sin theta by cos theta, which is equal to 2 times of tan theta. So this is the answer. Observe which option is matching here. Mu is equal to 2 tan theta. First option is correct. Okay, look at this question. A conveyor belt is moving at a constant speed of 2 meter per second. Okay, it is moving at a constant speed of 2 meter per second. Done. A box is gently dropped on it. Yes, it is dropped. The coefficient of friction between them is 0.5. Okay, they have given coefficient of friction, which is equal to 0.5. Okay, so let's say block of mass M. Initially it tries to move with the same velocity 2 meter per second, but there is a frictional force between block and the conveyor belt. That frictional force will make the object to come to rest position. Frictional force acts in the opposite direction of the motion of the block. So frictional force is F. It is represented like F. Okay. Now initially whatever the velocity this conveyor belt is having, the same velocity will be given to the block when it is gently dropped. The distance, the question they are asking, the distance that box will move relative to the belt before coming to rest. Okay, super. First of all, what should we have to do is we have to find out acceleration. I mean acceleration in the sense deceleration here, because frictional force is acting opposite to its motion. Let me find out frictional force first. Frictional force is equal to mu mg, as this block is on a horizontal surface. So this is frictional force. What about acceleration? Acceleration is equal to frictional force by mass, which is equal to mu into g. A is equal to mu value is 0.5 into g value is 10 meter per second square. They have already given in the question. So A is equal to 5 meter per second square. This is the acceleration which is acting on that block in opposite direction, nothing but deceleration. This is the deceleration. So let's say they said what is the distance traveled before it come to rest position, in the sense final velocity when it comes to rest position is equal to 0. Initial velocity is 2 meter per second. So whatever the conveyor belt velocity, the same velocity will be block velocity also. So let me use v square is equal to u square plus 2as formula. So final velocity is equal to 0. Initial velocity is 2 meter per second, that is equal to 4 minus 2 into 5 is into s. I just represented minus because it is a deceleration. So it is going to be 10s is equal to 4 and s is equal to 0.4 meter, and this is the answer. Question number 38, option B, A is correct. Hope you understood. Okay, let me solve question number 39. Now look at the question number 39. A block of mass small m is in contact with a cart C. Okay, this is cart C. Block of mass small m, it is always in contact with it. Okay. The coefficient of static friction between the block and the cart is mu. Okay. Coefficient of static friction between the cart and the block is mu. The acceleration of alpha or A of the cart that will prevent the block from falling satisfied. Okay, look at this. See, I should accelerate this complete cart towards right so that I can balance this block. Otherwise, if I move this cart towards left, that block will fall down. Okay, let's say this acceleration is A. With how much acceleration I have to accelerate so that block will be at rest position? That is the question they are asking. Okay, let me represent weight of the body. Weight is the direction of weight of the body, mg in a downward direction. Okay, what about normal reaction? Normal reaction is always perpendicular to the surface. Whenever you are applying or accelerating this cart towards right, there will be a pseudo force which acts on the object in opposite direction of its motion, which is equal to mass of the block into acceleration of the cart. That is called as a pseudo force. Understood ba? Whenever you are accelerating this cart, a pseudo force will act on this block. That is the reason it is at rest position, and the direction of that pseudo force is always opposite to acceleration of the container. Okay, what about the frictional force direction? This block is trying to slide down. That definitely frictional force acts in the opposite direction of its motion. They said the acceleration alpha of the cart that will prevent the block from falling. Okay, that means which value should be greater? Frictional force must be greater than the value of weight of the body, right? Then only the block will be in contact with that cart and it is not going to fall down or not going to slip. So that means frictional force must be greater than or equal to weight of that body. What about frictional force formula? Frictional force formula is mu into n, which is greater than or equal to mg. What is normal reaction? Normal reaction is nothing but pseudo force acting on it. Mu into small m into a greater than or equal to mg. M will get cancelled. Then a should be greater than or equal to g by mu. Look at the option which is matching for this. Option C is the correct answer. That's the answer which matches for this. Okay, hope you understood, guys. So let's solve question number 40. So try to understand the approach. So same kind of approach you may not get into the solutions or in the materials. So my approach is somewhat a little bit different from the actual answers. So my shortcuts are a little bit different from the remaining things. Just try to understand these shortcuts and utilize this opportunity very well. It will definitely boost your problem solving skills. Now, observe question number 40. A block B is pushed momentarily along a horizontal surface with an initial velocity v. Okay, let me consider a block of B. Initially it is moving with a velocity v. Okay, if mu is coefficient of sliding friction, this is a rough surface, so coefficient of friction is present, definitely frictional force will be present on this object. In which direction? In the same direction of its motion or in the opposite direction? Definitely in the opposite direction of its motion. What about normal reaction? Normal reaction is perpendicular to the surface. Weight of the body is downward like this. Here normal reaction is equal to mg. Now, as object is moving forward with some velocity v, there is a frictional force acting on this object, nothing but it will produces a deceleration on that object. Let me consider mass of the object is small m and let me find out deceleration. So F is equal to mu into n, which is equal to mu mg. Then acceleration is equal to F by m, which is equal to mu into g. This is the retardation acting on that block. Okay, so after certain interval of time, as retardation is present on the block, definitely the block will definitely come to rest position. That means final velocity is equal to 0. They are asking time after which this block is going to come to rest position. Acceleration is present, initial velocity is there, final velocity is there. Just simply use v is equal to u plus at formula. Let me find it. So final velocity is equal to 0, initial velocity is v, minus acceleration is mu g. I did represented as minus mu g just because this is a retardation, because frictional force is acting in the opposite direction of motion of the object, mu g into t. So I need to calculate t values, and mu g into t is equal to v and t is equal to V by mu G. Look at the option which is matching this. V by mu G. I think option D is correct. Check out that. Now, observe question number 41. A block of mass 10 kg, sorry. The coefficient of static friction mu s between the block A of mass 2 kg and the table shown in the figure is 0.2. Okay. So coefficient of static friction is equal to 0.2. Next, block of mass 2 kg. Super. Mass of the block is 2 kg. What would be the maximum mass value of block B so that two blocks do not move? Okay, we have to find out mass of this block so that these two blocks does not displace. That means F net acting on the system must be equal to 0. The string and pulley are assumed to be smooth and massless. Okay, whatever it may be. Now the question they are asking is we have to find out mass of the block B so that the system is at rest position. Okay. As block B is hanging, so force acting on this block B is downward, let's say, which is equal to mg, and this block A tries to move towards right with an acceleration A. This is also with an acceleration A. Tension in the string is away from the point of contact of block B. As this is a rough surface, there is a frictional force which acts in the opposite direction of motion of the object, which is equal to limiting friction. So mu s into n we have to find out. Normal reaction of this block is perpendicular to the surface n, which is equal to its weight, that is mg. That mg is nothing but 2 into g. They have already given the value of acceleration due to gravity. So 2 into g. G is nothing but 10, which is equal to 20. So normal reaction is equal to 20. They said the system is at rest position, right? Let me rotate this block B along horizontal direction so that it is going to be very easy for us to solve the numerical. Let me represent the system, stretched system along horizontal direction, 2 kg block, another block of mass m, we don't know. Its force is acting towards right mg, and frictional force is acting towards left, which is equal to mu s into n, where mu s is 0.2, n is 20, which is equal to 4. Okay, so 4 newtons. Mass of the block, only block A is on horizontal surface, not block B. So this is how it is represented. Complete system is moving towards right or left? No, it is not moving in any direction because the said system is at rest position. Okay, system is rest position in the sense right side force is equal to left side force. As right side force is equal to left side force, you have to equate mg is equal to 4, where g is equal to 10, which is equal to 4, and m is equal to 0.4 kg. This is the answer. Which option matches? Option D is the correct answer. Okay. Now question number 42. What's the question they're asking? Try to answer by pausing the video. A block of mass 10 kg placed on a rough horizontal surface having coefficient of friction mu is equal to 0.5. Okay. Mass of the block is 10 kg placed on a rough horizontal surface having coefficient of friction mu is equal to 0.5. If a horizontal force of 100 newtons is acting on it, then acceleration of the block. So what is the horizontal force acting on it? Horizontal force of 100 newton is acting on this block. Then we have to find out acceleration of the system. Okay. First of all, let me represent frictional force acting on this block. If applied force is towards right like this, definitely frictional force will act in the opposite direction of the motion of the object, which is equal to mu into n, where n is normal reaction, which is always perpendicular to the surface where object is placed. So weight of the body downward, which is equal to 10 into g. Let me consider g value as 10. You are going to get 100 Newton. Okay, so from this we just have to, let me draw free body diagram. So on this object, except normal reaction and its weight, two forces are acting along horizontal direction. Those forces are responsible forces for displacement of the object along the horizontal direction. Right side 100 Newton, left side is mu into n, where mu is 0.5 into n 100. System will move towards right with a acceleration. A mass of the block is 10 kg. We just have to decide whether it will displaces or not with the help of forces acting on it. If both the forces are equal and opposite, net force acting on the system is equal to 0, then object doesn't displace. Okay, now look at this. So it is going to be 50 newtons, right? So which is greater? 100 newtons is greater than 50 newtons. Then system will move towards right. Then A is equal to 100 minus 50 divided by mass of the block. Then A is equal to 5 meter per second square is the answer. Option B is correct. Question number 43. In this question, on the horizontal surface of a truck, a block of mass 1 kg is placed. Okay, so assume this is a horizontal surface of a truck. A block is placed. Okay, super. Mass of this block is 1 kg. Coefficient of friction between them is 0.6. Okay, truck is moving with an acceleration 5 meter per second square. Okay, so truck suddenly, or it is moving with an acceleration 5 meter per second square. It is moving towards right. Okay, if it is moving towards right, so what is the question they are asking? It is moving with 5 meter per second square. Now the question is the frictional force on the block will be super. Okay, when this truck is accelerating towards right, there will be a pseudo force which acts on this block, which is equal to mass of the block into acceleration of the container, which is equal to 1. Mass of the block is 1, acceleration of the container is 5. So it is going to be 5 newtons of pseudo force will act on this block. Okay, let us see. As this block is placed on a rough surface, there will be a frictional force which acts in the opposite direction of motion of the object. That means this is how the frictional force. See, frictional force is always opposite to motion of the object. Because of pseudo force, it may tries to move towards left. So frictional force must be towards right. This is the representation of frictional force. Let me find out maximum value of a friction present on that surface. What is the limiting friction formula? Limiting friction is equal to mu s into n. What's the value of mu s? It is 0.6. N is normal reaction, and normal reaction acting on that block is equal to mg. N upward, weight acting on that body is downward, mg. What's the value of m here? 1 kg. G value, let me consider it is equal to 10. So 1 into 10. So that is a normal reaction. Let me represent that here. So which is equal to normal reaction, and it is equal to 10. So frictional force, limiting frictional force is equal to 6 newtons. This is the limiting friction. This is the maximum value of frictional force. Okay, ma? So if you observe on the block, what is the magnitude of applied force acting on that body? Because of pseudo force, it is going to be 5 newtons. What's the maximum value of frictional force? So F limiting is equal to 6 newton. Will block displaces or will it be at rest position? Here for this block, 5 newtons looks like as if it is applied force. Here applied force is less than limiting friction. That's why block is at rest position. Block is at rest position. When applied force is less than limiting friction, the formula for static friction is equal to applied force. Whatever the magnitude of a force you are applying on that block, that will be equal to opposite force, which is equal to frictional force acting on that block, and the answer is going to be 5 newtons. That is the answer. So which is first option is correct. Very good. Next, a block has been placed on an inclined plane with the slope theta. Okay, 44 solution. They said a block is placed on the inclined plane. Angle of inclination is theta. So let me represent the block. Block slides down the plane at a constant speed. Coefficient of kinetic friction is equal to. So they said one key point. Just observe this key point. What is that point? Is block slides down the plane at constant speed. This is the point you have to observe. This is the hint point. So what is the meaning of constant speed? Acceleration is going to be 0 or non-zero? 0. Whenever object is moving with a constant velocity, acceleration of that object is going to be 0. Now let me find out what is the net acceleration acting on this object. So they didn't mention mass of the block. Let me observe, or let me consider mass of the block as m. So this is how block is placed on the surface. Mass m. Let me represent number of forces acting on it. So acceleration due to gravity, which is responsible for displacement of the object, is going to be g sin theta. We discussed it so many times till now. Frictional force will act in the opposite direction. What is the formula for frictional force? Frictional force is equal to F is equal to mu into N. What about N? Normal reaction. Let's say this is component, weight component. This is mg sin theta and this is going to be mg cos theta. Normal reaction is perpendicular to the surface, right? So this is how normal reaction is, and this is a frictional force. So F is equal to, they gave frictional force, coefficient of kinetic friction they are asking. Let's say this is kinetic friction. As object is under motion, we have to consider kinetic friction mu k into N is mg cos theta. Okay. So here mg sin theta is greater than FL. That is the reason object is moving down. So that is a point we can directly decide. And one more thing, it is moving at a constant speed. As v is constant, what about acceleration of the system? Acceleration of the system is equal to 0. As net acceleration is equal to 0, downward acceleration is equal to upward acceleration. Let me decide what are the upward acceleration and downward acceleration. Block of mass m, downward acceleration is equal to g sin theta. Upward acceleration is equal to frictional force divided by m. It is going to be mu k into g cos theta. I have to equate both of them. Then only net acceleration is equal to 0. So which is equal to g sin theta is equal to mu k into g cos theta. So here g will get cancelled out. What is mu k then? Mu k is equal to tan theta. So which option is correct? Option D is correct. Now question number 45. Consider a car moving along a straight horizontal road with a speed of 72 km per hour. Okay. Look at this. Initially it is moving with 72 km per hour. Try to convert 72 km per hour into meter per second. 72 km per hour can be converted into meter per second by multiplying it with 5 by 18, which is equal to 20 meter per second. 18 ones are 18 fours are. So which is equal to 20 meter per second. So that is what the first thing you have to do. So answer is in 20 meter per second. This is the initial velocity. Okay. Now if the coefficient of friction, static friction between the tires and the road is 0.5. Okay. So there is a coefficient of static friction between the tires and the road is equal to 0.5. Okay, which is equal to 0.5. So what is the direction of frictional force acts on this object? In the same direction of motion or in the opposite direction? Definitely in the opposite direction, which is equal to mu s into n. What's the mass of the object? Did they give mass of the object? No, they haven't given. First of all, find out acceleration due to frictional force. Frictional force S, which is equal to mu s, is 0.5. Let's say mass of the car is m. Normal reaction is perpendicular to the surface. So n, weight of the body is mg. So just equate this. N mu 0.5 into n will be there. So 0.5 into m into g. This is frictional force. What about acceleration due to frictional force? Nothing but a deceleration, which is equal to f by m, that is 0.5 into g value they have already given in the question, which is equal to 10 meter per second square. So this is 5 meter per second square. Is it in the same direction of motion of the object or in the opposite direction? This is a deceleration of the object. As it is a deceleration, object comes to rest position. So they're asking the shortest distance in which the car can be stopped. This is the question. Shortest distance that the car can be stopped. That means, let's say final velocity is equal to 0. They're asking us to find out the distance covered by it before it comes to rest position. So let me represent it with x, and formula v square is equal to u square plus 2as. That's the formula we have to use. Final velocity is equal to 0. Initial velocity is 20. 20 square is going to be 400 minus 2 into acceleration is 5 and it is s. So 10s is equal to 400 and s is equal to 40 meter. This is the answer. Option B is correct. Very good. Next. Wow. Next question is based on chain. Oh, super. Question number 46. So this question every student used to feel it is as very difficult. Let me try to make it as easy. Observe these diagrams, guys. Before solving this question, I would like to give one note. Observe this. Whenever you come across numericals based on chain, you just have to be aware of linear mass density. So linear mass density. The meaning of linear mass density is mass per unit length. Let me represent that with lambda. It is going to be mass per unit length. Let's say total length of this chain is going to be L and its mass is capital M. Okay. So for example, observe this note. For example, to find out. So for x length, what's going to be the mass? For length x, what is mass? What's the mass of chain? Mass of chain. Let's say that mass is a small m, which is equal to, so for x length from any one of the end, let's say from this like this. So what is going to be mass of this region alone? To find out that, we have a procedure. You just have to multiply that linear mass density into the length whatever they have given, which is equal to x, and it is can be represented as m by L into x. This is one procedure. I would like to give one trick. Just you can use it anywhere whenever there is a proportionality. So for L length, what is the mass? Capital M. For x length, what is going to be the mass? Just observe this procedure. I am giving a hint here. Let me represent this with 1, 2, and this is 3, and this is 4. I need to calculate 4. I have to calculate 4. To find out 4, what should I have to do is 4 is equal to 1 divided by 2 into 3. This is what I am going to follow. Okay, this is the rule I am going to follow. So from this you can follow this rule. That's m is equal to, that means m is the in fourth place, that is m is equal to x by L into m. So m by L is nothing but lambda into x. This is what I got again. This trick you can use for n number of numericals when there is a proportionality. Let's get into the numerical, what they have given and what we have to find out. Okay. A heavy uniform chain lies on horizontal tabletop if the coefficient of friction between the chain and the table surface is 0.25. Okay, they have given coefficient of friction mu is equal to 0.25. Super. Then the maximum fraction of the length of chain that can hang over the edge of the table. Okay, super. That can hang over the edge of the table. Total length is going to be L, mass is capital M. Remember that. So now let me imagine some portion, some x length of this chain is hanging. What is going to be remaining length? Remaining length is going to be L minus x. Are you guys observing? Try to understand carefully. So x length is hanging, remaining length is going to be L minus x. Super. Now on which chain, on which part of the chain frictional force is present? Is it on the L minus x length or x? X is freely hanging, so frictional force will act on the chain of length L minus x and its direction is towards left. So it is in the opposite direction of motion of the object. Okay, let me represent that. This is how direction of frictional force is present. What is the question they are asking? So this is frictional force and it is actually limiting friction we have to use. Always we have to use limiting friction to decide whether static force, frictional force or kinetic frictional force, whether we have to decide whether object is at rest position or under motion. This is going to be as they have given it is a static friction. Let me represent that as a static friction itself, which is equal to mu s into n. Normal reaction is perpendicular to the surface, so complete chain of length L minus x is present on the ground, so it is going to be weight acting on downward direction. Now I am naming these masses. L minus x length mass is going to be m2, so x length mass is going to be m1. I have to find out both m1 and m2. Let me find out that. Just now I gave you tricks how to find out m1 and m2. To find out m1 is equal to lambda into x, where lambda is m by L into x. What about m2? m2 is equal to lambda into L minus x, which is equal to m by L into L minus x. These are the masses of the objects. Okay, so what is the direction of weight of the body or chain which is hanging? So its weight acts from its center of mass. Let me represent that clearly. One more point they said is maximum fraction of length of the chain that can hang over one edge of the table. That can hang over one edge of the table. As it is hanging, both the forces, right side force and left side forces, both must be same, right? Then only it is at rest position, right? So one force which is present on this object, so right side, so its weight which is acting in downward direction, which is m1 into g. Now left side frictional force is acting. These forces must be equal, then only the system or chain is at rest position. That is, static friction is equal to m1 into g. Then only the chain is at rest position on the. What is the static friction? Static friction is mu s into n, which is equal to m1 into g. So what is normal reaction? Normal reaction is m2 into g is equal to m1 into g. G will get cancelled out. What's the value of mu s? Mu s is equal to 0.25. m2 value I already explained, that is m by L into L minus x, which is equal to m1 is m by L into x. M by L will get cancelled out. So 0.25 is nothing but 1 by 4. So L minus x is equal to 4x. L is equal to 5 times of x. So from this we can find out the part which is hanging. So which part is hanging here? X part is hanging. So then we can represent it as x by L is equal to 1 by 5. L is original length, x is the part which is hanging. If you multiply it with 100, you are going to get percentage. Actually 1 by 5 is going to be 0.2, right? So if you want to find out percentage of length which is hanging, just multiply it with 100, you are going to get answer as 20%. This is the way. So the approach is different. Try to understand, guys. Go through this numerical again and again, then you will get a clarity on this. So which option is correct? Option A is correct. Very good. Look at question number 47. Starting from rest, that means initial velocity is going to be 0. A body slides down a 45 degrees inclined plane in twice the time takes to slide down on the same distance in the absence of friction. Super. Thus an object is being traveling same distance on both inclined surface. One is a smooth surface, another one is a rough surface. So let's say time taken by this object to travel on smooth surface is T1, time taken to travel on the rough surface is T2. Okay. Now the time taken by this object on the inclined surface, let's say on rough surface is on rough surface is 2 times the time taken by the object to move on smooth surface. That is T2 is equal to 2 times of T1. You just go through this line carefully. So a body slides down a inclined 45 degrees inclined plane in twice the time taken to slides down the same distance in the absence of friction. That is the meaning over there. Okay. What's they're asking? They're asking the coefficient of friction between the body and the inclined plane. Okay. Let me find out T1 and T2 respectively. With the help of that we can solve this equation. Okay, so distance, let's say I'm imagining distance of this inclined plane is S. So here also it is going to be S. Distance of this inclined plane is S itself. Okay, super. Next step. So let me find out by using S is equal to UT plus half AT square. S is equal to UT plus half AT1 square. Initial velocity is equal to 0. Then S is equal to 1 by 2. A is acceleration due to gravity. On the inclined plane it is going to be G sine theta. It's not only G, it is G sine theta into T1 square. Let's say this is equation 1. Okay. Now look at the second equation. Second case, S is equal to UT plus half AT square. So S is equal to UT is equal to 0, 1 by 2. Here acceleration due to gravity is going to be slightly different because this is a rough surface. As this is a rough surface, there will be a frictional force which acts in the opposite direction of motion of the object. G sine theta is downward. Now here it is frictional force. Due to frictional force there is an acceleration which is acting in the opposite direction, which is mu G cos theta. So we know the formula for frictional force. If you want a clarity, it is mu into N, where mu into N is mg cos theta. So which is acting perpendicular to the surface. This is G cos theta. I am representing only acceleration due to gravity. So it is going to be acceleration due to gravity, which is due to frictional force, is equal to mu into G into cos theta. Now I have to consider net acceleration acting on that block, which is equal to G sin theta minus mu G cos theta into T2 square. Super. So with the help of this given data, we have to try to solve this equation. And one more thing, we know the information about T2 and T1. T2 is equal to how many times of T1? 2 times of t1. Let me substitute all these basics. S is equal, right? So I'm equating those equations. So this is equation 2. Now 1 is equal to 2. If I equate 1 by 2 into g into sine theta into t1 square, which is equal to 1 by 2 into g into sine theta minus mu cos theta into t2 square. 1 by 2g will get cancelled. Sine theta into t1 square is equal to sine theta minus mu cos theta into t2 is equal to 2 times of t1. It is going to be 4 times of t1 square will get cancelled out. Sine theta is equal to 4 sine theta minus mu cos theta. Then mu cos theta is equal to 3 sine theta. What's the value of theta? Theta is equal to 45 degrees. So this 4 is multiplied with this mu cos theta also, then it is 4 mu cos theta. So which is cos theta, sin theta will get cancelled because theta is equal to 45 degrees. 4 mu is equal to 3 and mu is equal to 3 by 4, which is equal to 0.75. This is the answer. Check out which option is correct. Option B is correct. This is the way to answer this question. Next question, 48. From now onwards, we are going to solve numericals based on circular motion. Okay. Question number 48. A block of mass 10 kg is in contact against the inner wall of a hollow cylindrical drum of radius 1 meter. Super. Let me represent the diagram. This is how diagram is. So what's the radius of the cylindrical drum? Hollow cylindrical drum. Radius is 1 meter. Okay. The coefficient of friction between the block and the inner wall of the cylinder is 0.1. Okay. So coefficient of friction they have given, which is equal to 0.1. The minimum angular velocity needed for the cylinder to keep the block stationary when the cylinder is vertical and rotating about its axis. Super. So this is the question, that the minimum angular velocity. Look at this. If this cylinder is at rest position, definitely that block will slides down. Okay. What is the weight of that block? Weight of that block is going to be 10 into g. They have already given m into g, which is equal to m is 10, g is also 10. You are going to get 100 newtons. This is the weight of the object. So as it is on the surface of that wall of the cylindrical drum. Now if this drum is at rest position, then that object will slides down. No, it should not be at rest. It should be rotated. What is the velocity with which I have to rotate? They are asking angular velocity. With respect to its axis, we have to rotate it. So let me rotate with an angular velocity omega. Now if I rotate like this, then there will be a pseudo force or a centrifugal force will act on this object. So normal reaction is always perpendicular to the surface, which is represented like this. As it is rotating like this, there will be a centrifugal force which is represented here. It is represented as omega square r, m omega square r. That is the centrifugal force acting on that block when it is revolving around this. So there will be a frictional force which acts on this block and surface opposite to its motion. Actually block tries to slides down, right? So frictional force must act in the opposite direction of sliding direction. So it is going to be frictional force. F is represented with mu into n. So they said what is the minimum angular velocity they are asking. Okay. For the object to be at rest position, which force should be greater? Either frictional force, is it frictional force or 100 newtons? Definitely frictional force must be greater than or equal to both cases. Let me consider frictional force is equal to 100 newtons, which is equal to weight of that body, then only this object is at rest position. Okay, so F is equal to m into g, where m is mass of that block. Frictional force is equal to mu into n, which is equal to m into g. So what is n here? N is nothing but m omega square r, which is equal to mg. This m omega square r is called as a centrifugal force. Centrifugal force, which always acts away from the are away from the center of this axis of rotation. Centrifugal force, mu value is 0.1, m is 10, angular velocity we don't know, that's what we have to find out. R is 1, mass is 10, acceleration due to gravity is 10. This 10 will get cancelled out. Omega square is equal to 100. If this 0.1 goes right side, it will become 100. Then omega is equal to 10 radian per second. This is the angular velocity with which this hollow cylindrical drum should rotate around its axis, so that the block which is on the surface of the wall will be at rest position. Superb question. Now look at the question number 49. One end of string of length L is connected to a particle of mass m, and the other end is connected to a small peg on a smooth horizontal table. Okay, super. Question number 49. Observe this question, guys. They said, if the particle moves in a circle with speed v on the net force on the particle, they are asking. Okay, let me consider this is a particle moving in a circular path. This is the point where it is tied. So this is where particle is. Particle mass is, let's say, m, and it is moving so with a speed v. Okay, so now the question they are asking is net force. As this object is moving in a circular motion with a constant speed, right? That they mention it is moving with a constant speed. No, they didn't mention. They said it is moving with a speed v. So this object is moving on in circular motion only because of centripetal force. Centripetal force is the force which is responsible for motion of the object in a circular path. That centripetal force is provided by tension in the string. Centripetal force on mass of the particle m is provided by tension in the string. Provided by tension in the string. That's why T is equal to centripetal force, which can be represented as mv square by r. R is length of that string. That length of the string itself is equal to radius. Next question. It's a concept, pure concept based question. Let me answer that. What is the answer for the previous question? Previous question answer is going to be option D. So centripetal force acting on that particle is provided by tension in acting in the string. Okay, look at question number 50. A car is negotiating a curved road of radius r. The road is banked at an angle theta. Okay, let me represent the data that they are asking. So 50, question number, try to understand the diagram. Car is negotiating. In this case, car is moving into the board. That's the meaning. Let's say angle of inclination is theta. So vehicle is moving into the board. This is the point you have to remember. Moving into mobile. Imagine like this. Okay, mass of the block, let's say m. What's the asking? The coefficient of friction between the tires of the car and the road is mu s. The maximum safe velocity on this road is, super. They're asking, they have given mu s value. What is the maximum velocity with which this vehicle can move on this curved bank road? Okay, super. Let's say as it is moving with the maximum velocity, there is a possibility that this vehicle may drift towards right with a centrifugal force m v square by r, where r is radius of that circular path. Okay, as it is trying to skid towards right, there will be a frictional force which acts in the opposite direction of the skidding. See, it doesn't move right side like this, it may move upward. There is a possibility if object is moving with the maximum velocity, then definitely frictional force must act in the opposite direction of its motion, right? Imagine carefully, you are moving on a vehicle, you are taking a turn on a curved road, that definitely there is a possibility to skid towards right. That towards right itself is this one. So frictional force must be opposite to its motion, right? Let me represent normal reaction. So normal reaction is always perpendicular to the surface. What about weight of the body? So weight of the body is downward. Okay, this is how it is represented, which is equal to mg. What's the question they're asking? They're asking maximum safe velocity. Now keep mg as it is. Now divide frictional force into two components. Let me represent that division of frictional force into two components. Try to understand, guys. This representation will be slightly different. Okay, so let me divide this frictional force into two components. One is horizontal component, another one is vertical component, like this. Okay, observe carefully. If this is theta, then this angle, opposite angle, is going to be theta, right? Then this component is going to be fs cos theta, vertical component fs sin theta. Okay, fs sin theta. Now divide normal reaction also into two components. Let us see how to divide normal reaction into two components. This is how it is going to be divided. One is perpendicular, another one is towards left, like this. Let me divide this. So if this is theta, definitely this is going to be theta. Then this component is n cos theta, and the remaining component is n sin theta. Now as object is at equilibrium position, try to equate the forces. Let me give you free body diagram. Now how many number of forces acting on that body, that I am going to represent here. So one is fs cos theta, another one is in the same direction n sin theta, one more force towards right, which is mv square by r, downward force is mg, and fs sin theta, another force vertically upward, which is n cos theta. Now we have to equate all these forces so that we are going to get the required answer. Let me equate all of them. I need v, right? Okay, let me equate. So it is fs cos theta plus n sin theta. Fs is mu s into n. N is mg cos theta, right? Instead of that, let me keep it as it is. fs is nothing but mu s into n cos theta plus n sin theta. These two values I am writing, okay, which is equal to mv square by r. Let's say this is equation 1. Next, n cos theta is equal to fs sin theta. That fs is nothing but mu s into n, right? Mu s into n sin theta plus mg. Okay, so from this, send this mu s n sin theta left side. N cos theta minus mu s into n sin theta, which is equal to mg. Let's say this is equation 2. Try to divide equation 1 and 2. Equation 1 divided by equation 2, which can be represented as mu s cos theta plus sin theta, which is equal to, I am cancelling n on both sides, divided by cos theta minus mu s sin theta, which is equal to cancel, v square by rg will be there. So this is the equation, but answer I need v V answer, but that too in terms of tan theta. Okay, so from this let me write down V. V is equal to Rg into mu s cos theta plus sin theta divided by cos theta minus mu s sin theta. Root will be there. Okay, so from this I need answer only in terms of tan theta. Then what we have to do is just common cos theta from this, then Rg into, you are going to get mu s plus tan theta. If you common cos theta, denominator also try to common cos theta, 1 minus mu s tan theta will be there into cos theta. Cos theta will get cancelled. Remaining answer is going to be V is equal to root of Rg into mu s plus tan theta divided by 1 minus mu s cos theta, tan theta. This is the answer. Which option matches? Rg into mu s tan theta by 1 minus mu s. Option D is the correct answer. Okay, next question number 51. 51 solution. Two stones of masses m and 2m are whirled in horizontal circles. The heavier one in radius r by 2 and the lighter one in radius r. The tangential speeds of lighter stone is n times that of the value of heavier stone. When they experience the same centripetal force, then the value of n is. Look at this diagram. So I've just represented as it is, whatever the head. Two stones of masses m and 2m are whirled in horizontal circles. Okay. The heavier one in radius r by 2 represented. 2m mass is of radius r by 2. The lighter one in radius r. Okay, lighter mass in the sense m. The tangential speed of lighter stone. The tangential speed of lighter stone in the sense, lighter one, that is m, which is equal to v1. So v1 is how many times of v2? The n times that of the value of heavier stone when they experience. So it is equal to n times of v2. This is the point they have given. That is the hint. Okay, and one more point. They experience the same centripetal forces than the value of n. They experience the same centripetal force in the sense the centripetal force of lighter mass and heavier mass is same. Let's say this is F2 and this is F1. F1 is equal to F2 or F2 is equal to F1. What's the formula for centripetal force? Centripetal force is equal to mv square by r, right? Okay, this is going to be m2 v2 square by r2, which is equal to m1 v1 square by r1. Okay, so which is m2 is 2 times of m, v2 square is v2 square divided by r2 is r by 2. Next, m1 is m into v1 square. V1 is n times of v2. v1 square is n 1 square times of v2 square divided by r1 is r. So this v2 square m will get cancelled. 2 goes to numerator, r will get cancelled out. Then 4 is equal to n1 square. Then n1 is equal to 2, not n1. So there is n. So which option is correct? Option 2 is correct. Very good. Next. Question number 52. A car is moving in a circular horizontal track of radius 10 meter with a constant speed of 10 meter per second. Okay. Look at this question, very interesting. A car is moving in a circular horizontal track of radius 10 meter. Okay. So there is a circular track. In which a car is taking a turn. Okay, so it is moving like this with a speed v. It is not possible to see whatever it is attached. It is a top view of that road. Let me get into the car and let me observe this. So this is how the view will be. As car is taking a turn like this, the things which are inside will drift towards right, correct? Drift direction. That is how it is. As a object, a bob is suspended from the roof of the car by a light wire of length 1 meter, super 1 meter length. The angle made by this wire with a vertical is super. As it is taking a turn, this will drift towards right, and that drift will be, let's say it is drifted like this. Let's say it is making an angle theta, and this is because of centrifugal force acting on it, which is equal to mv square by r. R is the radius of this circular track. Let's say this is our radius. R is equal to, they have already given, which is equal to 10 meter. Speed also given, which is equal to 10 meter per second. Super. The angle made by the wire they are asking. Super, super. Now let me try to equate the number of forces acting on this. I have to divide this t into two components. If this is theta, this is also theta. This is t cos theta, and this is going to be t sin theta. Weight of the object is downward, which is mg. Let me equate all these forces. If I can equate all these forces, t sin theta is equal to mv square by r, then t cos theta is equal to mg. Let's divide both the equations. Tension will get cancelled out. Tan theta is equal to v square by rg. So what is the question they are asking? They are asking angle made by the wheel. Okay, so from this let me substitute this. So tan theta is equal to, v is velocity is 10 meter per second square. It is going to be, 10 meter per second. 10 square is, it is going to be 100 divided by r is 10. G value, did they give G value? No, it is going to be, let's say it is 10, which is going to be 1. Then theta is equal to 45 degrees, which is equal to pi by 4. Which option is correct? Option C is correct. Super. So this is the way you have to think. Next, question number 53. So question number 53, solution. In question number 53, they said a car of mass 1000 kg negotiates a banked curve of radius 90 meter on a frictionless road. Okay, super. Road is banked. So mass is 1000 kg. Negotiates a banked road of radius 90 meter on a frictionless road. The banking angle is 45 degrees. The speed of the car they are asking. Okay, let me divide this again into two components. It is going to be mv square by r. Now weight of the body is downward, which is equal to mg. So divide normal reaction into two components. This is n, and this is going to be n cos theta, and this is n sin theta. So because this is going to be 45 degrees, which is, I am assuming it is as theta. So from this equate all of them. N sin theta is equal to m v square by r. What about n cos theta? N cos theta is equal to mg. From this tan theta is equal to m will get cancelled out. It is going to be v square by rg. Super. Tan theta, theta is equal to 45, as this is 45 degrees. So complete answer, it is going to be 1. Then v square is equal to rg. They're asking maximum speed, right? So then v square is equal to r value they have already given, it is 90 meter. G value, it is going to be 10. So v is equal to 30 meter per second. This is the answer. Option B is correct. 53. Super. Next, question number 54. Let me answer this. A car of mass m moving on a level circular track. Let me consider that level circular track. A car is taking a turn like this. Super. So as this is a top view, so this is top view or eagle view. Okay, question number 54, right? Okay, a car of mass m moving on a level circular track of radius capital mu s is represents the static friction between the road and the tires of the car. The maximum speed of the car in a circular motion is given by. So super. So whenever it is moving with a maximum speed, there is a possibility that it may skid towards right. So that skidding force is going to be m v square by r, which is equal to centrifugal force. As it is trying to skid towards right, then frictional force should act in opposite direction to its motion, and that frictional force is the static friction, which makes the particle to be at rest position. Super. So if you observe here, frictional force must be greater than or equal to centrifugal force, then only the object or the car doesn't skid on that road. So frictional force should be greater than or equal to centrifugal force, that is mv square by r. What is the thing I have to find out? I have to find out maximum speed of the car. Frictional force formula mu s into n. So normal reaction is perpendicular out of the board here, weight of the body is downward. Okay, if I represent the path here like this, car is moving towards right like this. So normal reaction is perpendicular to the surface, weight of the body is downward, that is equal to mg, greater than or equal to mv square by r. So here mu s into mg greater than or equal to mv square by r. M will get cancelled out. So what's the formula for v here? V should be less than or equal to root of mu s into rg, or else you can write it down as v is equal to root of mu s rg. Which option matches here? So for 54, option D is correct. Very good. Next, question number 55. Let me solve this. A gramophone record is revolving with an angular velocity omega. Okay, super. A coin is placed at a distance smaller from the center of the recorder. Okay, super. So from the center, a coin is placed. This is where coin is placed. Okay, this is revolving, so with an angular velocity, let's say I am imagining it is revolving with an angular velocity omega. Okay, so they have already given. So this is how it is represented. So with an angular velocity omega. Super. This is axis of rotation. A static coefficient of friction is mu. The coin will revolve with the record if. So I have to find out static friction. So what should be the centrifugal force acting on this coin? Okay, there is a, let me assume mass of this coin is m. Centrifugal force may act towards right, that is mv square by r. You can write it is as m omega square r, because they have given radius r and angular velocity. Static friction will act in the opposite direction, so which is Fs. It is not connected with the help of a string. Remember this point. Okay, so static friction is opposite to skidding direction. This is the way there is a possibility that it may skid. Which force should be greater? Frictional force should be greater, or centrifugal force should be greater? Definitely frictional force should be greater. So frictional force is going to be mu s into n should be greater than or equal to m omega square r. Here n is mg, which is greater than or equal to m omega square r. M will get cancelled. What is the thing I have to find out? R. So mu s into g greater than or equal to omega square r. Omega square r should be less than or equal to mu s into g. So where r is less than or equal to mu s into g divided by omega square. Which option matches? I think option D is the correct answer. Is it clear? Yes, it is. Super.